OSPF has 7 states. There are 7 states in OSPF neighborship. Number 1 is down state. Down means you have enabled the OSPF on interface, but that router is when actually we are enabling the OSPF routing protocol on the interface of router, that router will start sending hello message from that particular interface. ना हम ही हाँ जाइ छियै हाँ हाँ इन लेबै कनिक देर के बाद. Okay, first state is down state, second state is init state. Init means initialization. We will understand all state one by one, don't worry. This is our topic for the entire day. Today we will discuss only OSPF neighborship. Third state is two-way state. Two-way state. Fourth state is X start state. X start state. Fifth state is exchange state. Sixth state is loading state. And the last one is full state. Okay, last state is full state. Guys, full state means OSPF is working fine, there is no any problem, OSPF router have exchanged their database successfully, right? That means OSPF is working fine. If there will be some problem in OSPF neighborship, then a stack will stuck between loading to down. Between down to loading, in any states OSPF router can stuck. Done? Is it clear?
Yeah.
Okay. Mostly you will see OSPF neighborship will stuck in down state. In down state, in init state, usually we never seen that OSPF neighborship is stuck in init state. In two-way state also OSPF neighborship can stuck. In X start state also OSPF neighborship can stuck. After that, in exchange state and in loading state, you will not see usually OSPF neighborship stuck in these two state. These are very advanced topics. Like if there is some problem with hardware, then only OSPF neighborship will stuck in these two state. Otherwise OSPF neighborship will come in full state. Now understand all state one by one. Let's say here I have router 1 R1, and let me connect one router with this router. Control C, Control V, R2. Both are directly connected with each other. Here IP, here this is my R1, and this is my R2. Here let's say IP address is 12.1.1.1. Here let's say IP address is 12.1.1.2. Done. Now to configure OSPF on router number 1, you will run command router OSPF. After that, process ID. Now understand what is the concept of process ID in OSPF. Here you will define process ID. Process ID. Guys, process ID is nothing but the identification of OSPF process. Means we can run multiple OSPF process on a single router. We can run multiple OSPF process on a single router. So how we will identify the process? How we will differentiate the process? So that's why we have concept of process ID in OSPF. Let's say on router number 1 I am running two OSPF process 1 and OSPF process 2. We are running OSPF process 1 as well as OSPF process 2. That means we are running two number of OSPF process on router number 1. Now concern is maybe this interface where IP address is 12.1.1.1 belongs to process 1 or maybe belongs to process 2. So we can run the simple things that you need to keep in mind here is we can run more than one process on a single routers. That's why we have concept of process ID in OSPF to differentiate the process. Done. If you want to see the range of process ID, let's say here I have router 1, and on router number 1 if I am running command router OSPF and after that question mark, so you can see the range of your process ID. You can use any number from this range as a process ID, and it is not compulsory that process ID should match on both router to become neighbor. This is not like ES number. In ES number, in ESGRP, ES number should match to form neighborship. Yes or no?
Yes.
But this is not ES number, this is locally significant process ID. We can configure any process ID on router number 1, we can configure different process ID on router number 2, then also this router can become neighbor. That means routers are not exchanging process ID in their hello message or in their update message, in their any message of OSPF. This is locally significant. This is locally identification of a router. Router 2 don't need to do anything with the process ID of router 1. In the same way, router 1 don't need to do anything with the process ID of router 2. This is locally significant. Done. If I will talk about the range, so you have seen the range 1 2 6 5 5 3 5 6 5 5 3 5. Done. Okay, after that this command will only allocate some memory to OSPF. Now we need to actually enable OSPF on the interface. Yes or no? Let's say this is F0/0 0/0 and this is also F0/0 of router 2. Now we need to enable OSPF on the interface of router, because as you know routing protocols work on the interface, on the interfaces, not on the routers. So with the help of network command you will advertise this interface. So I can run network and then 12.1.1.0 and after that wildcard mask. You all know wildcard mask now? Is wildcard mask clear to everyone?
Yes.
What will be the wildcard mask over here?
It should be 0
0.0.0.255,
55.
because subnet mask will be 255.255.255.0. So this will become wildcard mask. Okay, after running this command, OSPF will enable on which interface of router 1?
First 0/0.
0/0. This is the first way to enable OSPF on the interface. Okay, after that here OSPF work on the basis of area concept. So this is not the complete command. Here we need to add one more keyword, that is area. OSPF work on the basis of area. In upcoming day you will understand why OSPF works on the basis of area, what is the benefit of it. So here I can define any area. There are two types of area in OSPF. One is backbone area and one is regular area. Backbone area means area 0, and any regular area means all area except area 0, like area 1, area 2, area 100, area 500. Any area except area 0 is known as regular area. So let me configure area 0 over here. This is the complete command. Getting my point?
Yes.
This is the first way to enable OSPF on fast Ethernet 0/0. Or the second way is just you need to go to interface F0/0, and on that interface you can run command IP OSPF. After that process ID is let's say 1, and then area, I can say 0. This is the also one command to enable OSPF on fast Ethernet 0/0. Both method you can use any one method. Either you can use this method or you can use this method. Here you don't need to define wildcard mask. Just you need to write IP OSPF 1 area 0. So this router will came to know, okay, this interface is going to belongs to area 0, and on this interface I am going to enable OSPF process 1.
So the
Fine.
process number is like by default we can use like 1 or 2, whatever we want.
Yes, this is process ID.
Okay.
You can use any number from this range 1 2 6 5 5 3 5.
Okay.
Done. Is it
Yes.
clear to everyone?
Yes.
Okay, so this is how we enable OSPF on fast Ethernet 0/0. Now, after enabling OSPF on fast Ethernet 0/0, what fast Ethernet router will do? Router will start sending one hello message from fast Ethernet 0/0, right? It will start sending hello message. It will start sending hello message. But guys, tell me, will router 1 receive any hello message on fast Ethernet 0/0? Until and unless I will not configure OSPF on router 2. Until and unless I will not configure OSPF on router 2, router 1 will not receive any hello message on this interface on F0/0. It is only sending hello message because we have enabled OSPF only on router number 1 now. Am I right?
Yes.
So the interface which is only sending the hello message but not receiving any hello message, that interface will consider as down in OSPF. That interface will consider as down in case of OSPF. Done. Am I right? Is it clear?
Yes. Yes.
Here, so CDP neighbor. Okay, let me configure one IP address over here on router number 1, F0/0, F0/1. I'm going to down this interface. On router number 2 also, I'm going to down F0/1. Just I'm going to use F0/0 of both router 0/1. Say shut down. Done. I have done. Now I am going to configure IP address first on router 1 and router
So why,
2.
so why do you shut down? You have to do no shutdown.
No, actually, on fast Ethernet 0/0 and on 0/1, on both interface, I had run command no shutdown. So on 0/1, just I have run shutdown command. Getting so IP interface brief. You can see your fast Ethernet 0/0 is up. Your fast Ethernet 0/1 is down. Okay. Got it, guys?
Yes, got it.
Fast Ethernet 0/0 is up and fast Ethernet 0/0 is 0/1 is down. Now I am going to configure one IP address here on fast Ethernet 0/0 interface F0/0. Say IP address 12.1.1.1 255.255.255.0. Oh my god, there are lots of pain in my chest while speaking. Okay, so here I have assigned this IP address 12.1.1.1. Done. Now I am going to assign IP address on router 2 also. So let me configure one IP on router 2. Interface F0/0. IP address is 12.1.1.2 255.255.255.0. Done. On both interface of router I have configured the IP address. Now I am going to check the connectivity between router 1 and router 2 because router 1 should be able to ping router 2. So let me verify that. Ping 12.1.1.2 and you can see I am able to ping, right? So that means there is connectivity between router 1 and router 2. Now I need to configure OSPF between router 1 and router 2. So first I am going to configure OSPF on router number 1. How to configure OSPF? Command is very simple. Router OSPF, after that 1, and then guys you need to define the router ID. If you will not define the router ID is what? Router ID is nothing but the identification of router. Like your name, what is the use of your name? Through your name we are identifying you in your family, in your friend circle, right? In everywhere through your name we are identifying you. Like OSPF also need to identify the router. Actually OSPF exchange the database. After configuring OSPF on both router will exchange their database. So when let's say router 2 will receive database of router number 1, how it will identify that this is database of router 1? With the help of router ID. with the help of router ID. If you will not define the router ID, then router will check is there any loopback exist on this router. If loopback is exist, then whatever IP address you are running on the loopback interface, that IP address will become router ID. This is dynamic method. Okay. There are two ways to configure a router ID on OSPF router. First, manual, and second is dynamic. In dynamic, first router is going to check loopback. If loopback is exist, so the IP address which is running on loopback interface, that IP address will become router ID. If loopback is not exist on router, then router is going to check the IP address on physical interface. So as you can see on router number 1, physical interface F0/0, IP address is 12.1.1.1. So this IP address will become what? Router ID. Do show IP protocol. You can verify by running command again show IP protocol. Here we are able to see what is the router ID of router 1. Right? Or the second way is manually we can configure router ID 1.1.1.1. Router ID is just IPv4 representation. Okay. So now I have manually configure router ID 1.1.1. I manually tell to router 1 your router ID is 1.1.1.1. Okay.
So
and now
that one is a loopback, right?
that is not
1.1.
loopback. That is not loopback. This is manual configuration. I am not running this IP address on any interface of router number 1. I can configure any IP address as router ID. I can configure 100.100.100.100. I can configure 255.255.255.255. This is the manual method. If you will not define manually, then it will consider, it will check is loopback exist. If loopback is exist, then that IP address will become router ID. If loopback is not exist, then physical interface IP address will become router ID. Because on router number 1 you can see loopback is not exist. Yes or no?
Yes.
If I will remove this command, say no, and now if you will check do show IP protocol, so you can see now router ID is 1.1.1. If I will say no router ID 1.1.1, no router ID 1.1.1.1 and do show protocol, now you can see what is the router ID again.
Oh, the interface, physical
And
interface.
if I will create one loopback here, interface loopback 1, and let's say on loopback interface IP address is 100.100.100. 255.255.255.0, let's say. Now there is one loopback interface, so do show IP protocol. Now you can see router ID is still what? 12.1.1.1. But if I will clear the OSPF process, do clear IP OSPF process and say yes. And now if you will check router ID, so router ID will become what? Loopback interface IP address. Router ID will become loopback interface IP address. You can see still router ID is this one. Do show IP interface brief. I think loopback is running or not. Yes, loopback is running here. That is 100.100.100.100. So router should select this IP address as router ID. Do show protocol, and it is, you know, this is the router ID. Actually, you know, there is one more concept. ONS router will elect one IP address as router ID until and unless that IP address will not goes down. Router is not going to change the router ID. Router is not going to change the router ID. Do clear IP OSPF process. If I will clear the OSPF process, that means we are resynchronizing the OSPF process. So again it should now change the router ID. But here you can see still router ID is what? 12.1.1.1. But if I will run new process here, say no router OSPF 1. I have removed the OSPF configuration. Now you can see do show protocol. There is no any routing protocol running on router, and router OSPF 1 and do show IP protocol. Now you can see router ID is
Loopback. Okay.
okay. And if there are more than one loopback, let's say on router number 1 there are two loopback. One is 100.100.100.100 and one more loopback is there, that is let's say 200. 200.200.200. Now router will be elect which IP address as router ID? The higher IP address. The higher IP address will become router ID.
Okay.
So the concept is very clear. Once we will configure OSPF on router, we have two options for the router ID configuration. One is manual and another one is dynamic. In manual you will simply define the router ID, and in dynamic router is going to check loopback. If loopback is exist, then the IP address which is running on loopback interface, that will become router ID. If there are more than one loopback exist on the router, then higher IP address on loopback interfaces will become router ID. If loopback is not exist on the router, then physical interface IP address will become router ID. Loopback is logical interface and fast Ethernet 0/0 is physical interface. If there is more than one physical interface exist on router, then higher IP address on physical interface will elected as router ID. Okay, so the best way should be, you should configure it manually. The best way is you should configure router ID manually. Router ID is 1.1.1 like this, and do so protocol. You can see now router ID is 1.1.1.1. Is it clear?
Yes.
Is it clear, guys, to everyone, to all people? If anyone have confusion, please let me know.
No, I think Soha is not here.
Okay, so what is router ID? Router ID is identification of router in OSPF domain. It is an 32 bits address represented in IPv4 format, and we have two methods to configure it: manual, dynamic. Manually you can configure the router ID, or router is going to elect one IP address of interface dynamically, automatically as router ID. Is it clear?
Yes.
Now if you will run command show IP OSPF interface brief, so you can see I am not running OSPF on any interface. Till now OSPF is not enabled on any interface. So how I can enable OSPF on interface? We have two options again. One is through network command. We can run network 12.1.1.0 wildcard mask 0.0.255, and then area is, let's say, 0. This is the one way. And now you can check do so IP OSPF interface brief. OSPF is enabled on fast Ethernet 0/0, and state here, guys, state is what? Waiting. Why state is waiting? Okay, so you will understand a state later. Okay, don't worry, we will discuss about this state later, because there is concept of DR and BDR. That will be a separate topic. Fine.
Okay. Yes.
So this is the first way to enable OSPF. Now I am going to remove this command. Say no network 12.1.1.0 0.0.0.255 area 0. Now again you can see OSPF is not enabled on any interface. Now let me show you the second method to enable OSPF on the interface basis. Interface F 0/0, and here I can say IP OSPF, then process ID, and after that area 0. This is also one command to enable OSPF on interface. Okay,
I think this is the easy one.
yes, this one is the easy one, and I am also using this method to configure OSPF. Fine. Till
Yes.
here, is it clear?
Yes.
Okay, now in privilege mode I can check so IP OSPF interface brief, that we are running OSPF on which interface, on how many interfaces. So OSPF is enabled on F 0/0. Done. And IP address of router 1 is 12.1.1.1. State is waiting, and this is the metric cost. So we will understand the metric calculation in OSPF also, like EIGRP. In EIGRP, how routers calculate metric by using formula 10⁻⁷ upon least bandwidth plus total delay upon 10 whole multiplied by 256. In OSPF, metric calculation is different from EIGRP. We will understand what formula OSPF is using for the metric calculation. But for now, just keep in mind this, the single things. In OSPF, we called metric to cost. We called metric to cost. So this is metric of fast Ethernet 0/0. Now if I will check the detailed information on this particular interface by running command show IP OSPF interface fast ethernet 0/0, I can use this command to check the detailed OSPF configuration of this interface. So here when I am running this command, guys, so IP OSPF interface fast ethernet 0/0, you can see fast ethernet 0/0 is up, line protocol of this interface is up, internet IP address is 12.1.1.1, area of this interface is 0, process ID that we are running on this interface is 1, router ID on this interface is 1.1.1, network type is broadcast, we will discuss it later, cost is 1, we will discuss it later, enabled by interface, how you have enabled the OSPF on this interface by the interface configuration. Okay, after that transit delay we will discuss about this DR and priority later, designated router later, we will discuss interface IP address is 12.1.1.1. okay, after that hello time is 10 second, date time is 40 second, date time means hold on time, and wait time is 40 second, retransmission time is 5 second. Okay, so we will discuss these things later. For now here you don't need to focus on any other things. Okay, this is just a troubleshooting command of OSPF. Fine, is it clear? After that,
Yes.
if I'm putting question mark here, I don't have any option, so IP OSPF interface, and then I can use one detailed command as well here, I think. Is there any option to run detailed? No. Okay, I can use brief command, and after that interface brief will show me the this output. Okay, fast ethernet, and then interface ID 0/0, and then we don't have any option here. Okay, so till now we had discussed these three commands of troubleshooting. Verification command, one is show IP protocol. In the show IP protocol output we are able to see routing protocol is OSPF process 1. We don't have configure any filtering, so okay, leave it. After that here also you can check router ID, and maximum path that this router can install is 4. Number of areas in this router is 1. Only one area I have configured, yes or no, on this router, that is area 0. After that we are performing routing for fast ethernet 0/0, and what is the distance value of OSPF is 110. What is the distance value of EIGRP? AD
90.
value 90 and 170. What is the distance value of RIP?
120.
120. And what is the AD value of OSPF? 110.
110. Yeah, 110.
110. So if brother I have a prefixes from RIP also, same prefix from EIGRP also, and from OSPF also, so which routing protocol is preferable? Which
Through
routing protocol is more reliable?
like about what? Like through what? Through
Here AD value is 120, here AD value is 90, and here AD value is 110. Yes or no? So as you know, list AD value always preferred by router.
then EIGRP.
See, if router is running a same network from these all routing protocol, router will prefer EIGRP. Yes or no?
Yes.
Okay, is it clear? And now a state of this interface fast ethernet 0/0 is down because it is not receiving any hello message on this particular interface. How I can check that? We can debug. This is also one verification command, debug IP OSPF. After that, not IP, let's say, okay, IP OSPF, debug IP OSPF and say hello. So with the help of this command, I can see hello message on router number 1. Whatever hello message router 1 will generate, it will generate one log message. After 10 seconds, it will generate one hello message, yes or no? See, send hello to what address? 224.0.0.5. Area 0, fast ethernet 0/0. Address from which interface? From 12.1.1.1. It is sending hello message from fast ethernet 0/0 after every 10 seconds, yes or no?
Yes.
But it is not receiving any hello message here. It is not receiving any hello message here. So I am going to say unall to disable the debugging, and show IP OSPF interface brief. This command we already discussed. Now you can see state is DR. Now state is DR, so we will understand DR and BDR concept later. Okay, so till now just I have configured OSPF on router number 1, and this interface state is down, and we are not able to see the state is down anywhere. So IP OSPF, or let me run so OSPF IP OSPF and then question mark. After that I can use what here, process number. See guys, these are the command to check the neighbor also. So IP OSPF neighbor similar like EIGRP, but now I am not going to use this command. I'm telling you here you can use the process ID. Process ID which I am running on this router is 1, and then again if you will put question mark, it is asking you to define the area. You can define the border router interfaces. We will understand these things later, and after that I can run one command here, that is timer, and then okay, so these are different command. You don't need to do anything. Let me check. I am forgetting one command here. Actually I want to show you that command only, neighbor, and after that am I getting any option? Fast ethernet 0/0. No, so there is no neighbor. Like by using this command also I can check, is there any neighbor on fast ethernet 0/0? So now it's saying there is no any neighbor on fast ethernet 0/0. Yes or no? On any
But
interface like this you can check. Yes.
we have neighbor.
No, we don't have any neighbor because I have not enabled OSPF on router 2 till now.
Okay, got it.
Got it? And now if I am putting question mark here, let me check the detailed information. So in detailed information also we are not able to see anything. Fine. Then okay, like loopback interface also I can check, on fast ethernet link also I can check. So this is the command after neighbor, and let me remove the neighbor here. Let me put the question mark, process ID 1. If I am running this command, see this is also one command. In upcoming day we will understand reference bandwidth. Here you are able to see the reference bandwidth somewhere, or SPF algorithm execution. As I told you, SPF is an algorithm that OSPF uses for best path selection. EIGRP uses dual algorithm. OSPF uses SPF algorithm. OSPF stands for what? Shortest path, sorry, open shortest path first. Open means it is an open standard, and shortest path first, that means SPF. SPF is an algorithm that OSPF uses to calculate metric. And are you able to see reference bandwidth somewhere, guys?
Bandwidth.
Reference bandwidth. Reference bandwidth, where it is? Let me use one keyword here, include reference. No. So IP OSPF process 1 By using this command, we are not able to see the reference bandwidth, or is there any information about reference bandwidth here? No, we don't have reference bandwidth information here. So IP OSPF, and then I should use the process number 1, and after that OSPF area. No, I don't need to do anything with area here. Interfaces, neighbor, LSAs. This is the command to check reference bandwidth. I think I need to check again. Where is the reference bandwidth? Let me check, guys. Just give me a second. Okay, if we are not able to see the reference bandwidth value here, what I can do, I can run one more command here. So IP OSPF interface fast Ethernet 0/0. Here we are able to see reference bandwidth. No. So let me do one thing, how to check reference bandwidth. Check reference bandwidth in OSPF. What is the command? Let me open any link. So IP OSPF. Only I need to run so IP OSPF command. So IP OSPF. That's it. Okay. So here, are you able to see reference bandwidth somewhere? Let's say include what is the command here? Let me copy this command and let me paste it over here. No, by using this command also we cannot check the reference value. How is saying that? Okay. Okay, I will check reference value later, and I will make you understand how OSPF is calculating their cost. Before that, now I am going to configure OSPF on router number 2. You know, down state means what? Down state means router 1 is sending hello message from fast Ethernet 0/0, but it is not receiving any hello message on fast Ethernet 0/0. So this interface will consider as down interface. Done. Once it will receive any hello message on fast Ethernet 0/0, state will move from down to init. Getting my point? Down state means not receiving any hello message. Okay, and it is sending hello message. Once it will receive the hello message, state will be moved to init. State will be moved to init, and we cannot see the down state right on router. Now I am going to configure R2, guys. Here on R2 I am going to run command router OSPF 1 and then router ID, let's say 2.2.2.2. After that I need to enable OSPF on interface, so interface F0/0 and say IP OSPF 1 and area. See, like in EIGRP, to form EIGRP neighborship, AS number must match. In case of OSPF, area must match. Area must match. So what area I have configured on router number 1? Area 0. So area should be same over here as well. If I will configure area 1 here, then OSPF neighborship will not come up. See.
So the area should be the same, but the process number, if it's different, doesn't matter.
Yes, process number can be different. See the log message as well. Invalid packet, mismatch, area ID. Getting my point? It is giving you the error message as well that your area ID is not matching. Yes or no?
Yes.
On router number 1 also you can see so IP OSPF neighbor. Is there any neighbor? No. Why? Now you need to troubleshoot it. Why? So what command you will run here? So IP OSPF interface brief, and here we are able to see this interface area is 0, and on router number 2 also I will run same command. So IP OSPF interface brief, and here I am able to see area is 1. So that is the reason. So I will correct it. Go to again interface F0/0. First of all, let me remove this command from here. Say no IP OSPF 1 area 1, and now I am going to say IP OSPF 1 area 0, and so IP OSPF neighbor. Now you can see OSPF neighborship is in full state, but behind scene guys you have to understand these all states. Here we are able to see directly full state. Yes or no? On any router, on router number 1 also you can see so IP OSPF neighbor. My neighbor is 2.2.2. 2.2.2 is router ID of router 2. What is the IP address of neighbor? 12.1.1.2. And this neighbor is located on which interface? This neighbor is located on fast Ethernet 0/0. And neighborship state is full. Got it? When it is going to declare their neighbor date after 38 seconds, but after 10 seconds again it will receive one hello message for 34, 33, 32, 31, 30 and 39. Getting my point? So you can see this timer is resetting after every 10 seconds. Means both router are sending hello message after 10 seconds. And hello message is periodic in nature. It is periodic in nature. Periodically both routers are sending hello message. You can debug on any router. Let's say on router number 1 I am going to debug IP OSPF hello. So see here, it is sending hello message as well as receiving hello message. Send hello message, received hello message. Received hello message from 2.2.2. Send hello message, receive hello message. Okay. Now these two routers will be exchanging their hello message for the lifetime after every 10 seconds.
So what's the main purpose of a debug? Why we run debug?
Oh, your voice was breaking.
Okay, can you hear me now?
Yes.
So what's the main purpose of a debug? Why we use debug?
Debug to check that which messages routers are sending. Like I want to check how many hello messages, or I want to check, let's say between router 1 and router 2 OSPF neighborship is not working fine. So what you will do? First you will check that router 1 is sending hello message or not. Yes or no?
Yes.
Because routers uses hello message to form neighborship. If neighborship is down, that means router are not sending hello message. There is some problem in hello message.
Okay.
Getting my point?
Yeah, we just use that one for neighborship, right?
Yes.
Okay.
Just to check the neighborship. Any message if you want to check, like update message or any other message, on all. First of all, let me disable it. Any message, let's say I want to check that router is sending CDP message or not. CDP is a protocol. Okay, in upcoming day you will understand CDP protocol in switching. If I want to check the router are sending CDP message or not, so I can debug CDP. So it will start generating one log message of CDP message. Whenever router will send any CDP message to router 2, it will give you one log message. That's it. To generate log message, I am using this feature on Cisco iOS. This is a feature of Cisco iOS. Getting my point?
Yes.
Is it clear?
Yep.
Okay. So first state is down state. After that, init state. So when router is only sending hello message, it is not receiving any hello message, then state will be down. It is very clear. When router will receive the hello message, then state will move to init, right? And guys, one thing, when router send hello message, router include their router ID. Router include their router ID inside the hello message. Like see, router 1 is sending this hello message to router 2. So inside this hello message, there will be router ID of router 1. This hello message router 2 is sending to router 1. There will be router ID of router 2. Means who is sending the hello message? There will be router ID. Getting my point? So when router will send the first hello message to router 2. Now till now router 1 don't know anything about router 2. Router 1 don't know what is the router ID of router 2. Yes or no? You tell me now, router 1 have information about router 2 or not?
No. Not
No,
yet.
because earlier, until and unless router 1 will not receive any hello message from router number 2, it will never came to know what is the router ID of router 2.
Yes.
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 So, okay, till here it's fine that initially both router will send their hello message with their own router ID. But when router 1 will receive hello message from router number 2, now router 1 have information what is the router ID of my neighbor, yes or no?
Yes.
So in next message, in next hello message, it will share two information. One, my router ID is 1.1.1.1 and my neighbor router ID is 2.2.2.2. In the same way, when router 2 will send the next hello message, it will send their own hello message as well and their own router ID as well and their neighbor router ID as well. My router ID is 2.2.2.2 and my neighbor router ID is 1.1.1.1. Not in the first hello message, in the second hello message. After receiving the hello message from neighbor. Yes or no?
Yes.
So that means inside the hello message there is one field called active neighbor. Inside the active neighbor field, router will put router ID of their neighbor. And when router will see in active neighbor field, router will find their own router ID. Then only a state will move to two-way state. Then only a state will move to two-way state from the init state. Getting my point? So see guys how neighborship is working. Let me make you understand again. Again I have one router here, R1, R2. Done. First it will send one hello message with their own router ID 1.1.1.1. It and I have not configured OSPF on router 2, so this interface will consider as down. Right? Once it will receive hello message on this interface with router ID 2.2.2.2, neighborship state will move to init, right? And it will check active neighbor field. So in active neighbor field there will be no information of neighbor router ID, yes or no, because this is first hello message. So state will be here. After some time, after 10 seconds, again router 1 will send one hello message, yes, where router ID will be 1.1.1.1 and neighbor router ID will be 2.2.2.2. So once router 2 will receive this hello message, it will see their own router ID inside the hello message, yes or no? So neighborship state will move to two-way state. Two-way state means, you know, bi-directional connectivity. Means router are getting their own router ID in hello message, like router 1 is getting their own router ID in the hello message of router 2 and router 2 is getting their own router ID inside the hello message of router 1. That means there is bi-directional connectivity. Both router are sending their neighbor router ID in the hello message Am I right?
Yes.
So until and unless router will not put their neighbor router ID in the hello message, neighborship state will not move from init to two-way. But definitely in second hello message you will see it will send the it will send the neighbor router ID. Done. After that, in two-way state there is some concept. There is concept of DR and BDR. So when we will discuss DR and BDR, then you will understand what is the purpose of this state, two-way state. You know, two-way state is the third state of OSPF neighborship, and it is used to find that should I form full neighborship adjacency with neighbor or not. Should I need to form full adjacency with neighbor or not? Let's say, brother, what's your name? Let's say Abdul. Where are you, Abdul? Are you
I'm
here?
here. I'm here. Yes.
Yes. Let's say me and Abdul, right? We don't know each other, right? But Abdul and me both are living in same society. Both are living in same society. Let's say Abdul is my neighbor. Abdul house is just beside my house, but we don't know each other. Okay, now we want to form a close neighborship. I want to form a close neighborship with Abdul. So first I will tell, hey Abdul. Then Abdul will say, hey Praful. After that I will say, hey Abdul, I am Praful and I know you. That means I am sending the router ID of Abdul as well in next hello message. Yes or no?
Yes.
So once Abdul will see that Praful is sending hello with my address, with my identification, that means there is two-way connectivity. Okay. Now we are in which state? We are in init state.
Your screen is moved to.
Yeah. Don't worry.
Okay.
Okay. So we have exchanged hello message. In the hello message, we have here the neighbor information as well. So both are in init state. Now we will move to two-way state because we both have seen their own identification in the hello message. So we are going to move in two-way state. In two-way state, I will match something. I will ask to Abdul, hey Abdul, do you like non-veg? If Abdul will say yes, and let's say I don't like non-veg, let's just say I love non-veg, by the way. Okay, let's say I don't like. So I am the people who is forming the neighborship only with those people who don't like non-veg. Getting my point? So you tell me, will I form full adjacency with Abdul or not? No, because here my criteria is not matching. Yes or no?
Yeah.
If Abdul and me both are, liking the non-veg, then we can move to next state. Then we can move to access start state. If we both are not compatible with each other, then we will till here will two-way state. That means I know Abdul know me, but we are not going to exchange anything. We are not going to exchange the food. Getting my point?
Yes.
So this is also a kind of neighbor, but this is not the full neighbor. In OSPF, there are two types of neighbor. One simple neighbor, means only we know each other, and the second type of neighbor is the full way neighbor. In full way neighbor, we exchange everything. Whatever food I will cook in my house, I will share with Abdul, and whatever cook Abdul will food, whatever food Abdul will cook in Abdul house, it will share with me. That means we are full neighborship. We have full neighborship. Okay. So it depends. OSPF routers also, decide that our neighborship should be till 2A or should be full. So,
So
2DR, yes.
the two-way neighborship has no benefits. They just know each other, and if they cannot
Yeah,
send,
they are not going to exchange the routing information.
then what's the benefits of their neighborship?
So you will understand this. What is the benefit? Benefit is we know each other. I know Abdul. Abdul is my neighbor. Okay.
Mhm.
Let's say you are the new person who have newly, taken the room beside us. Getting my point? So I can tell to you that brother Abdul is living beside me who love non-veg. If you want to form neighborship, you can form with him. Yes or no?
Yes.
So you guys can exchange the food with each other, but I will not exchange the food with Abdul. Getting my point?
But if we change the food, it should be through you, right? Because you know him and you know me as well.
Hmm.
So you
Hmm.
will be the border, right? The
Yeah.
main.
Yeah.
So if you cannot exchange anything with me, how you can exchange my food with other guy with Abdul?
No, no. Let's say what I am saying,
Mhm.
that I am not going to exchange any food with Abdul, right?
Mhm.
And Abdul is not going to exchange any food with me. But Abdul will exchange the food with you, and you can exchange the food with me. There is no neighborship. There is neighborship, but till two-way between me and Abdul.
Yeah.
But between you and me, and between you and Abdul, there is full neighborship. So I can exchange my food with you. Abdul can exchange the food with you, but I and Abdul cannot exchange each other.
Okay.
Got it? So in two-way, routers are actually going to decide that my neighbor is only neighbor or my neighbor is full-way neighbor, full-way adjacency. There are term called two types of neighbor are there in OSPF. One is neighborship without adjacency, neighbor without adjacency. Let me write here, neighbor without adjacent, and one neighbor is neighbor with adjacent. Getting my point?
Yeah.
So neighbor without adjacency is not going to exchange the database, and neighbor with adjacency are going to exchange the database. Got it? So now in my scenario, see, these two both routers are neighbor with adjacency, neighbor with adjacent. So IP OSPF neighbor full way. Full way means there is neighborship as well and adjacency as well. Getting my point? But let me do one thing here. I am going to configure interface F0/0 and IP OSPF priority 0 and router number 2 also. I am going to run this command. Later on you will understand the meaning of this command. Interface F0/0 IP OSPF priority 0. Just wait. I am going to clear IP OSPF process now. Clear IP OSPF process and say yes. And now if you will check OSPF neighborship, so IP OSPF neighbor, see, neighborship is
Two-way.
two-way, till two-way only. That means now these routers are not going to exchange the database. Getting my point?
Yes.
In next class, in tomorrow class, I will make you understand DR and BDR. Then you will understand how neighborship will stuck in two-way. How neighborship will stuck in two-way state. For now, just try to understand there are two types of neighborship in OSPF. In EIGRP, there is only one neighborship, that is full. On OSPF, routers are going to exchange their hello message. They are going to form the neighborship and they are going to exchange the complete database routing table. But in case of OSPF, the process is little bit different. Okay, in this state, bidirectional connectivity will checked by router in two-way state. Okay, and the concept is very simple. DR and BDR form neighborship, full neighborship with all other routers, but DR other and DR other cannot form full neighborship with each other. So it is confusing for you for now, but in next class it will be very easy. It will be very easy to catch. Okay, the
Yes.
concept. Then again I am going to form the full way neighborship here. Interface f0/0. I am going to remove this command which I have run here. Say no, and on router number 2 also I am going to say no to this command. Okay, and again if you will check neighborship, so IP OSPF neighbor, again you can see neighborship is
Full.
full. Okay, so after two-way neighborship state is X start. So OSPF neighborship is going to move to X start. Okay, there will be only two things in two-way state. Either routers will stuck in this state or routers will move in X start state. Yes or no?
Yes.
Either routers are going to stuck in two-way state. If router will stuck in two-way state, that means router are not going to exchange the database, or router can move in X start state. Okay, now in X start state, the first thing that router is going to do is it is going to match MTU. What is MTU?
I think load balancing.
Maximum we had discussed in OSI
Yeah.
model.
Maximum.
Maximum transfer unit. By default MTU of Cisco devices is 1500 byte. By default MTU is 1500 byte. Done. So in X start, router are going to check MTU. If both router are using same MTU value, then only neighborship will move to exchange state. Otherwise neighborship will stuck in exchange state. Getting my point? See how to check the MTU first. So IP interface f0/0. If I am running this command, so IP interface fast Ethernet 0/0, are you able to see MTU?
Yes, yes.
And
1500.
MTU of router 2 is also, so IP interface f0/0. Here also MTU is 1500. By default MTU is 1500. So on both router MTU is matching. That's why your neighborship state is moving from X start to exchange. If MTU will mismatch, let me change the MTU of any one interface. On router number 1, I am going to set MTU, let's say not 5500. IP MTU, I'm going to say 1400 byte here, right? And again I am going to say clear IP OSPF process. Say yes. And now if you will check OSPF neighborship, so IP OSPF neighbor, now you can see neighborship is stuck in which state? In which state neighborship is stuck, guys? In X start state. Why? Because MTU is mismatch. So if your neighborship is stuck in X start state, what troubleshoot you will do? You will check MTU value. You will run command so IP interface f0/0, and then you can say include MTU also. Like this also you can check. MTU is 1400 byte here, and on router number 2 you will run so IP interface f0/0 and say include MTU. You can see here MTU is here MTU is 1500 byte. So MTU is matching. That's why OSPF neighborship is so IP OSPF neighbor. OSPF neighborship is stuck in X start state. Getting my point?
Yeah.
So now I have two options. Either I can change the MTU value, or I can ignore. I can tell to OSPF, please brother, please OSPF routing protocol, don't check MTU value in X start state. Getting my point? So whatever method you want to use, you can use any method. So you tell me which method you want to use.
You need to move MTU back, the one we added.
You want to ignore it? So go to interface f0/0 and say IP OSPF MTU ignore. That's it. This command will ignore the MTU. And now again you can see so IP OSPF Neighborship is full. Fine. So if MTU will match, then neighborship will move to which state?
Exchange.
Exchange state. Guys, in X start state, few more things will happen. You know what? How routers are going to negotiate the MTU? Because in hello message does not carry MTU value. Okay, so see here again I am going to design one topology, R1, R2, very simple. I know you are learning OSPF for the first time, so maybe it is complicated for you to understand the concept, but don't worry guys, in upcoming day by day you will understand everything. Don't worry. This is F0/0, this is 0/1, here IP address is again 12.1, here IP address is again 12.2. You know, when OSPF neighborship will move to two-way state, after that routers are going to exchange the DBD. Router 1 will send one DBD to router 2. DBD. And router 2 is also will also send one DBD message. Now question is, what is DBD message? So DBD stands for database description, and this is second type of OSPF message. If I will talk about types of messages in OSPF, let me write here types of messages in OSPF. So see, we have multiple types of messages like in EIGRP. Can anyone tell me how many types of messages are there in EIGRP? Hello, update, query, reply, and acknowledgement. Am I right?
Yes.
In the same way, OSPF have also some messages. First message is hello message. Second message is DBD message. DBD. Third message is LSR message, link state request message. Fourth message is LSU message, and fifth message is LSAC message. So these are the 5 types of message of OSPF. We have 5 types of message in OSPF. You already know hello message. What is the use of hello message? Hello message is used to form neighborship. Yes or no?
Yes.
And DBD message is used to exchange the sequence number. It is used to negotiate the MTU value. It is used, you know, in X start state. Now, what is the purpose of DBD? Guys, suppose, you know, here I am turning on my camera. Oh, so my camera is okay. If let's say you are, you know, you are planning for a dinner with your family. Let's suppose you are planning for dinner tonight. So you will, you know, enter in the restaurant. Am I right? After that, in the restaurant, once you will enter in the restaurant, do you think that directly waiter will give you the food? No. First of all, waiter will give you one menu card. Yes or no?
Yes.
On the menu card, there are description of all the food which is available in that restaurant. Yes or no?
Yes.
So what is the purpose of DVD message? DVD message is similar like the menu card. Let's say router 1 have some number of networks. Let's say router 1 have some networks, network A, network B, and network C. And router 2 have also some network, let's say network X, network Y, and network Z. This is like food in the restaurant. This is like food in the restaurant. Router 1 have these prefixes and router 2 have these prefixes. So first, through DBD message, these router are going to tell. Router 1 is going to tell to router 2, brother, I have network A, I have network B, I have network C. If you need any network from these, you can let me know. I can share the detailed information with you. Like food. Food is the detail, you know, actual things which you want, right? You don't want menu card. Through menu card, just you are checking that what things that restaurant have. Yes or no?
Yes.
So through DBD message, routers are sharing the which networks I have actually. Getting my point? And in this DBD message, it will share MTU value, that is 1500 byte. In the same way, router 2 will share DBD message, and in the DBD message it will share description of X network, Y network and Z network. And then there will be MTU information. MTU is nothing but 1500 byte. Done. Is it clear?
Yes.
This is X start state. X start state. In X start state, routers exchange DBD message, or interviewer can ask you question like, how interviewer can ask you question like, routers exchange DBD message in which state? So router exchange DBD message in which state? In X start state. Router negotiate MTU value in which state? In X start state. Getting my point?
Yes.
Okay. After that, both router have exchanged their DBD message, and let's say MTU is matched. MTU is matched on both router. Now router need, let's say router 1 need the detailed information of XYZ. Let's say you have the menu card and you want to order some food. You want to order like chicken lollipop. Lollipop chicken. This is Indian, I think, dish. So what you will do? You will request for that, yes or no, to waiter.
Yes.
In the same way, routers are going to request for the detailed information of XYZ network in the form of third message, that is LSR. 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 Link state request. It will send the link state request for XYZ network. X, Y and Z. Or let's say this router 1 have already X or Y network. So it will not request for Y, it will request for X and Z only. Or maybe it will request for all the network X, Y and Z. Yes or no? That can be possibility. It is not compulsory that whatever foods are inside the menu card, you will order all the food. Yes or no? You will order the specific food from the menu card, or maybe you can order all the food. Yes or no?
Yes.
In the same way, it will send LSR message to request for the detailed information of these network. And this is LSR, and this message will be sent by router in which state? In loading state. But there is one more state between loading and X start, that is exchange. So guys, in exchange state, this is actually exchange and X start state, combination of both state. In X start state, it will send the empty DBD. Inside the DBD, there will be nothing. And after exchanging the empty DBD, it will share LSA's header. In which state? In exchange state. In exchange state. And in loading state, router will send LSR. After that, router 2 will send what? LSU. It will send the detailed information of these network in the form of LSU. LSU link state update. And after that, it will send, router 1 will send the acknowledgement message. Acknowledgement message. This all things will happen in loading state. Acknowledgement. And after exchanging the database, neighborship state will move to full state. To full state. Getting my point?
Yes.
Full state means router have already exchanged the database. OSPF is working properly fine. Okay. Now let me show you these things practically once. I am going to open GNS3. here I have explained, detailed information, but just you need to keep in mind the overview of these things. That in which state router exchange which type of message. What is the meaning of down state? What is the meaning of init state? What is the meaning of two-way state? What is the meaning of X start state, the exchange state, loading state, and full state? I'm going to take two router here, router 1, router 2. On router number 1, I am going to create some loopback. Router 1, router 2. Topology is visible to you now, guys?
Yes.
Yes.
OSPF is very intelligent routing protocol. That is the reason why we are using this routing protocol as well. Here, let's say IP address is 12.1.1.1 and here IP address is 12.1.1.2. Okay. After that, let's say we have some loopback on router number 1. That is 10.1.1.0/24, 10.1.2.0/24, and 10.1.3.0/24. Done. And let's say router 2 have also some loopback. These are food of a restaurant 20.1, 20.1.2.0, 20.1.3.0. Done. So topology, hope topology is clear.
Yes.
Topology is clear to you?
Yeah, it's clear.
First of all, I am going to configure the IP addresses on this device. Here I have router 1. This is my router 1. And here I have router 2. On router number 1, let me configure the IP first. Interface F0/0, say no set, and IP address 12.1.1.1, 255.255.255.0. Exit. Interface loopback 1, IP address is 10.1.1.1, 255.255.255.0. Interface loopback 2, IP address is 10.1.2.1, and interface loopback 3, IP address is 10.1.3.1. Done. I've configured the IP address on router 1. So IP interface brief exclude unassign, you can see. Okay. Okay.
Yes.
Okay. Router 2 interface F0/0, say no set, and IP address is 12.1.1.2, 255.255.255.0. Exit. Interface loopback 1, IP address is
Yes.
interface loopback 1, IP address is 20.1.1.1, 255.255.255.0. Interface loopback 2, IP address is 20.1.2.1. Interface loopback 3, IP address is 10.1.3.1. Right. Now, if you will check the routing table, so IP route, we have directly connected network only, right? Router 2 don't know about 10 network. Yes or no, which is running on router number 1. And in the same way, router 1 don't know about the network which is running on router number 2. Am I right?
Yes.
Because we have not configured any routing protocol. Now, before configuring routing protocol, I am going to capture the link so that I can show you all the traffic which router 1 and router 2 is going to exchange with each other. Done?
Yes.
Okay. So on router number 1, I am going to configure OSPF, a router OSPF 1, and then router ID 1.1.1. Okay. I've configured the router ID. After that, I am going to enable OSPF on interface F0/0. I'm going to say IP OSPF 1 and area 0. It will start sending hello message from this interface. Yes, you are able to see the hello message.
Yes, you can see that.
Okay. But router 2 is not sending any hello message because on router number 2 I have not enabled OSPF, and I need to enable OSPF on loopback interface as well. So interface loopback 1, IP OSPF 1 area 0, interface loopback 2, IP OSPF 1 area 0, interface loopback 3, IP OSPF 1 area 0. I have enabled OSPF on all interface. So IP OSPF interface brief, you can see OSPF is enabled on these all interface. Done guys.
Yes.
A router OSPF 1, sorry, a router OSPF 1 and passive interface loopback 1, loopback passive interface loopback 1, passive interface loopback 2, passive interface loopback 3. I have configured passive interface on loopback interface so that it should not generate hello message on loopback. Done.
Yes.
There is no any neighborship, so IP OSPF neighbor. Done. Now I am going to configure R2. On R2, a router OSPF process 1 or any number I can use. Router ID 2.2.2.2, then interface loopback 1, IP OSPF 1 area 0, interface loopback 2, IP OSPF 1 area 0, interface loopback 3, IP OSPF 1 area 0. After that interface F0/0, IP OSPF 1 area 0. So IP OSPF neighbor. Now OSPF neighborship state is OSPF neighborship is not showing. So IP, okay, now OSPF neighborship state is, you can see here, full. And here are you able to see the messages? Description message DBD database description. First, see guys, both router are exchanging hello message. Earlier router 1 was sending only hello message. After that, this is the first hello message of router 2, 12.1.1.2. Yes or no? Then the hello message of, I'm going to stop the capturing because I don't need to check any more information. See the first hello message which router 1 is sending to router 2. I'm opening the hello message of router 1. Okay, inside the hello message of router 1, if you will check the detailed information of hello message, here you can see inside the hello, this hello message, router ID is 1.1.1.1. Is there any information about neighbor router ID?
No.
No. Why? Because router 1 have not received any hello message from router 2. So how router 1 will came to know what is the router ID of router 2? But see, this is the hello message of router 2. After receiving the hello message of router 2, this is the hello message which router 1 is sending. After receiving hello message of router 2, router 1 is sending their hello message. If you will open this hello message, inside this hello message you can see router ID is 1.1.1.1 and active neighbor router ID is, that means this time router 1 is sending router ID of router 2 as well inside their hello message. So state will move to two-way state. After that, after two-way state, next state is access start state. In access start state, router send what? DBD. So which router is sending DBD first? 12.2 means router 2. Let me open the database description of router 2. If you will check this, see, is there any information about the network? Because router 2 need to send this network, yes or no?
Yes.
But in the first DBD message, we are not able to see any network information. Yes or no? This is DBD message. This is DBD message of router 2. Inside this DBD message, we are not able to see any
Network information.
But here we are able to see the MTU value. Yes or no? So this is null DBD message. Null DBD message is used to negotiate the MTU. Fine. In the same way, router 1 will also send the null DBD message. See this DBD message 12.1 is sending to 12.2. Inside this DBD message also you can see there is no any network information. Am I right? There is information of MTU only. Okay. After that, state will move to exchange state. In exchange state, again routers are going to send what? DBD. So see, this is 12.1. 12.1 is sending this DBD message. Let me open this DBD message in detail. In this DBD message, you can see here there is information of LSA. Yes or no? LSA, if you will open this, you can see guys, there is information of advertising router ID 1.1.1. And is there any network information? Okay, I think I have opened the wrong DBD message. Not this one. OSPF DBD message and LSA1. Inside the LSA1, this is option field. Okay, we don't need to do anything. Advertising router ID is this one, and external option is different. Router have sent, you know, this is GNS3, it is sending two null DBD message, but in real time it will send only one DBD message. Here you can see message type is DBD. By yourself you can connect to router, you can capture the link, then you can configure the OSPF and you can verify these types of message, DBD message. In 2 DBD message, router have not sent any information of network. But if I will open this message, this is LSR, link state request message. But before link state request message, it should send one description message of all prefixes. Let me check once again here. .1.1.2. Okay. It have notes here. Here one message is missing. But if you will open the request message in loading state, let me open this, or this description message which router 1 is sending to router 2. In this description message, you can see it is sending the header of it should see here header of all prefixes. Where is LSA? Database description. Okay. And interface MTU. This is also null DBD.
What is null DBD?
Null DBD means without carrying any network information.
Okay.
Here in this LSR, link state update, we are able to see that who is sending this message 12.1.1.2 to 12.1.1.1, and it is sending these network information. Yes or no?
Yes.
20.1.1.0, 20.1.2.0, 20.1.3.0. It is sending these all network. These are just header, no detailed information. These are just a header, not the detailed information. Then router will send the LSR message. You know, tomorrow I will show you this in EVNG. Here output is something different. Output is wrong. Here one message, one database description is missing, guys. Okay. So don't worry, don't focus much on it. Tomorrow we will see it in EVNG, and there hope it will share, you know, all messages correctly. On real devices, first router will send hello message, hello. After that, null DBD. In which state? Hello message will be sent by router in which state? In all state. All states. Null DBD will be sent by router in which state? X start state. Okay. Then actual DBD message will be sent by router in which state? In exchange state. And then LS R will be sent by router in which state? Loading state. LSU will be sent by router in which state? Loading state. LSU, LSAC in which state? Again in loading state. And after exchanging these all messages, neighborship will move to full state. Full state means database has been exchanged between router, right? And now on router number 1, if you will check routing table, so IP route OSPF, you can see router 1 have learned these all prefix. Getting my point? AD value is 110. In the same way, router 2 have also learned all prefix of router 1. So IP route OSPF. Okay. But the important thing that you need to understand in OSPF is so IP OSPF database. This is the database of router. You have to understand this. How router build the database. How router build routing table with the help of database. How router can design an entire topology with the help of database. So our next topic will be types of messages. Okay, types of messages we already discussed. How router build database. But before that, yes, tomorrow we will discuss these types of messages by capturing the traffic between two routers. Okay.
Okay.
That's all for today, guys. If you have any doubt, you can ask, because today, I am feeling difficult.